Okay, we're on our final related rates video. This is day 3. In the first video, we did 3D geometric figures with volume. You could also do surface area. Second video was trying right triangles, which involved sides and using the Pythagorean theorem. And now we're going to do more right triangles, but these involve trig functions because we're dealing with angles here. So let's go ahead and go to this problem right here so that you know what I'm talking about. So we have a man that walks in a straight path at the speed of 4 feet per second. Searchlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the searchlight rotating when the man is 15 feet from the point closest to the searchlight? So we're going to go ahead and draw this picture here. So we have a searchlight right here. I'll color it yellow. So here it is. This thing's on the ground and it's following this man. So here he is. He's walking. This man is walking like this. Okay. We have a distance right here from the searchlight, and this distance is 20 feet. And then this man right here is traveling at 4 feet per second. I'll put an M here for the man. So let's go ahead and start doing some givens here. So he's walking dm dt 4. Okay. It's located 20 feet from the ground. What am I looking for? I'm looking for, well, let's finish this triangle up real quick. This is theta. I'm looking for d theta dt. So what is d theta dt when the man is 15 feet? And I'll just throw feet per second up here. Okay, so this is everything that we do know. So this person's walking away. This is rotating. Okay. So this hypotenuse right here is opening, 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 and opening as we go. All right. So we have to think of some relationship with this triangle. And since we have angles involved, we have to use trig. So in this case, it's actually going to end up being tangent. So we're going to have tangent theta equals opposite over adjacent. If you notice, the 20 feet is a constant. It's not changing, so I'm just going to put the constant value in there, make life a little bit easier. So if I solve for m, I'm going to get m to equal 20 tangent of theta. And this is the hard part to set up. Once you have the setup, you're good to go. So we're going to go ahead and ready to take the derivative now. There's no other substituting. I just have my two variables. I'm going to get a dm dt when I take the derivative. I'm going to get a d theta dt. And then I might need a little helper equations in here to start solving some stuff, but I'll get there when I need it. So when I take the derivative, I'm going to get dm dt equals the derivative of tangent is secant squared. So it's going to be 20 secant squared theta. You got to tag it d theta dt. That's a time sign. Okay, so this is my entire setup. Now, what I do want to do here is there's a couple options. Is you can just go ahead and find your theta, plug it in, and go from there. So that's always a viable option. I usually use some type of substitution for a problem like this just to make it a little bit easier on myself. It's a little bit less work. But I do have almost everything here. I have the dm dt. I just need to find the secant squared theta. And I really don't want to find the secant squared theta because I have to do a little bit more work here, and I don't really want to do that much more work. Now, you could find secant, but I'm not going to. I'm actually going to substitute that in for, there's actually a formula that you learned in pre-calculus which substitutes out a secant squared. You remember what it is? It's tangent squared theta plus 1. Okay? So now I know what tangent is. So I need my little helper equation here. So it's m over 20, but at this 15, tangent theta is equal to 15 over 20 at this instant, which actually reduces down to 3 over 4. So now I'm ready to go. I can start to plug everything in here. So dm dt is going to be 4 equals 20 tangent squared. So tangent is 3/4. I'm going to square that plus 1 d theta dt. So I'm going to get 4 equals 20. If you go off to the side here, 3 over 4, they're going to square each of those, plus 1 is going to give me 9 over 16 plus 1, which is 9 over 16, plus 16 over 16, which is 25 over 16. So we get 25 over 16 d theta dt. And then I can start to kind of simplify from here. 20 goes into 16 how many times? It should be, so this cancels out to be 5/4. So I'm going to get 4 equals 125 over 4 d theta dt. Yeah. And then I'm just going to finish off the problem right over here because I'm running out of room. Multiply both sides by this 4 over 125. And I'm going to get 8 over 125 equals d theta dt. This is a perfectly good answer. I'm going to want units on it. And I'll show you what the calculator answer looks like as well. So this is 8 over 125. Any one of these problems is always going to be radian. So it's radians per time. Our time is seconds. It's d theta dt. And then if you're to use a calculator, 8 over 125, I already have that for you, is 0.128 radians per second. It will accept either one of these answers. So voila. There's your right triangle, dealing with an angle type of related rates problems. Hardest part here is going to be the setup. Once you get that, it's pretty good. Again, these are usually set up all the same way. I get rid of secant squared just so I can use tangent squared plus 1. You don't have to. I do that. If you were to do secant squared, you would get this 25 over 16. Either way, does not matter. You would just need to solve for the hypotenuse at that time. So I just want to show you the substitution way, that way that I like better. I think it's a little less work, but that's just me. All right. Hope you enjoyed the video.